Hello, and welcome to Boedeker Plastics' presentation titled How Detectable Are Metal and X-Ray Detectable Plastics. My name is Jim Hebel, and I'm Boedeker's Technical Service Manager. And this is a presentation that we delivered to this year's International Production and Processing Expo in Atlanta, Georgia. We got excellent feedback and a lot of good comments, and so we wanted to make this information available to others via additional media outlet. And so we certainly appreciate you taking the time to listen and hopefully learn about detectable polymers. Really, why we got into this was the fact that advanced engineering plastics have been used for many, many years in the food, beverage, and pharmaceutical manufacturing industries. However, fairly new and very misunderstood are the use of both metal detectable and X-ray detectable versions of these polymers. So today we want to go through some of the myths associated with these, clear up a little of the misunderstanding, and actually show you some data so you have some understanding of what you can expect as far as detectability level of these polymers. And again, try to clear up some of the confusion that might be out there. So we thank you for joining us. The way this will work, about a 23-minute presentation or so. And the agenda will look like this. First, we're going to touch on why and how metal detectable and X-ray detectable plastics are enhancing food safety today. Going to talk about why the level of detectability in these polymers is so important. In fact, we're going to talk about how manufacturers make these plastics detectable as well. I think if you have an understanding of how the manufacturers make these products detectable, you have a little bit better understanding of how they can be utilized and also what level of detectability can you expect. And finally, we'll look at some data. And with the data, we're going to hopefully give you an idea of exactly what size piece of plastic you can expect to see as detectable in your process. So we'll jump right in, and first off, let's talk about why detectable materials are important. Why are they being used? And it's a simple answer. They're being used because of contamination. Contamination is bad. Contamination is bad for consumers, can result in a laceration hazard, a dental hazard, a choking hazard, right? You find something in your beverage or in your food that you didn't expect, and obviously that can lead to a bad situation, so bad for consumers. Beyond that, it's certainly bad for business as well, bad for the manufacturer of the product. Contamination can lead to production stoppages and having to contain that contamination and hopefully contain it within the walls of your manufacturing facility. You spend a lot of time, a lot of effort, and a lot of costs to figure out what happened and contain that. And should the contamination get outside the walls of your building and get out into the public, you can see huge costs just start to pile up from not only product recalls, but then beyond the recall, trying to rebuild trust in your brand or in your image as well. So all in all, contamination just bad for everybody. Now, detection equipment is in place today to stop contaminants and find contaminants that are in the product. Very common in manufacturing today is the use of standardized metal and or X-ray detection systems. Now, with the potential for the huge costs that I just talked about and the liabilities due to contamination, now more than ever, it's important for all components within a manufacturing system to be able to be detected, and they should be detectable using this existing detection equipment. That's important. I mentioned that plastics have been used for many, many years already, but the fact is they've been ignored for many years. And when I mean ignored, I'm referring to their ability to be detectable. In the past, plastics would break off, fall into the yogurt, and hopefully somebody would see it, but beyond that, they would not be detectable by the metal detectors or the X-ray detection equipment. So why is that? Well, the fact is plastics are not typically detectable by these systems. For metal detection, they're not detectable because they're not magnetic, right? So detectors looking for metals are not going to pick up plastics. And X-ray detectors work by looking for a contrast in material density. And you need that contrast in material density to pick up the contaminant. And most plastics have a density close to that of water. And so as a result, that means they're oftentimes not detectable in X-ray detection systems either. You need heavier materials like metals to be able to be seen in the X-ray detection equipment. So with plastics not being very detectable and contamination being such a huge concern, isn't the easy answer for manufacturing folks to continue to use metals and things like stainless steel in their manufacturing equipment? Well, that's what a lot of folks have done. But the fact is, now today, more and more, plastics just offer tremendous value if they can be utilized. Just a tremendous benefit over metals and over stainless steel. Plastics oftentimes offer things like they're just lighter weight, up to 7 or 8 times lighter weight than metals. So that alone can offer some tremendous efficiency. Plastics also tend to offer improved chemical and corrosion resistance, which can be huge, especially with some of the more aggressive cleaners that are being used today. Plastics are also self-lubricating. Inherently self-lubricating. So they oftentimes offer a lower coefficient of friction. They offer improved wear performance, and all of that oftentimes without the use of oils, greases, or lubricants, which are really contaminants themselves. So plastics can offer tremendous efficiency savings, overall efficiency savings through less maintenance, less downtime, and more uptime. So obviously you can see if plastics can be used, they offer the tremendous benefit. So with that being said, it's imperative for manufacturers in food, beverage, and pharmaceutical industries today to take advantage of those advantages and to use plastics. But more importantly, they need to be using detectable plastics to take advantage of those benefits, but yet still ensure protection from product contamination. Now the good news is there's also an extensive selection of materials that are available with detectability options. Here's a few of them listed here. Ultra high molecular weight polyethylene, used a lot in these industries today. It's a very tough material, a very abrasion resistant material, so just great for wear applications. Polyoxymethylene or acetyl is a 200-degree material that's very machinable, holds tolerances pretty well, and another material very common to this industry. Polyamides or nylons are a 200-degree material that really offer unmatched wear performance, just long life in wear applications. PET or polyesters offer improved performance above nylons and acetyls in regard to dimensional stability and chemical resistance. Beyond that even further are materials like PTFE with extremely low coefficient of friction and a lot of slickness. And polyether ether ketone or PEEK, material that handles temperatures well over 300 degrees with just tremendous dimensional stability and excellent chemical resistance. So there are options out there today in the whole gamut of polymers that are available in materials that are both metal and X-ray detectable options. Now, how are these materials made to be metal detectable? Well, metal detection, how do you make a product detectable with metal detectors? You have to put metal in it. So basically metal powders are put into the polymer. For X-ray detectability, you have to put powder in as well, but in this case it's a barium powder. The barium filler is what enables the material to be able to be seen on the X-ray detection systems. So these powders are blended into the raw material resin, compounded in prior to them being extruded or injection molded. Now the key here is the actual level of material, of additive that's put into the product. You need enough material to make the material detectable, but you don't want enough filler that you compromise the integrity of the material itself. So too much filler can actually embrittle the material and make the material more prone to breakage. So it's really a detectable, or it's really a critical balance as to how much filler you put into these products. And actually, metal detectable and X-ray detectable plastics have been around for quite a few years already. But the use of them has been a very slow build. Of course, today with contamination issues, more and more folks are looking to these detectable polymers for safety reasons. But the fact is, they're still quite misunderstood. They're misunderstood by both users and also by the folks that are manufacturing these detectable plastics. And when I say misunderstood, I'm referring to what is the actual level of detectability of these materials. What is the actual size that I will be able to detect of these plastics in my process? I'll hopefully show you some of that with the data that we're going to provide. Before we actually do that, I need to mention one thing right up front. Something that's pretty important to understand is these detectable plastics cannot and will not ever be as detectable to the same levels as stainless steel or even other ferrous or non-ferrous metals. You're making these plastics detectable through the use of an additive, and just inherently they're not going to be as detectable, and so that's certainly important to understand. Now, the FDA mandates that a 7 millimeter contaminant must be able to be detected with 100% accuracy. So that means a 0.28 inches or 7 millimeter contaminant must be detectable. This is the size contaminant that the FDA deems as a choking hazard. Now, my understanding is this is the point at which someone can take legal action if they find something that's greater than 7 millimeters in their product. Now, the good news is most of these detectable plastics all meet this requirement. In fact, as far as the plastics industry goes, they've pretty much adopted a 3 millimeter cube as a good rule of thumb for what should be considered as the smallest piece of plastic detected by existing systems. So that's the material size that is detectable typically. However, every process is different, and with every process comes different environmental variables. And what do I mean by these different environmental variables? These are things that can actually affect the level of detectability. The food itself or the product itself that's being manufactured, there's different complexities, there's different volumes that are being manufactured. All of that will play a role as to how detectable the plastics are in the product. The moisture level of the product. Is it wet? Is it dry? That plays a role. Also the temperature. Is it a very cold process or a very warm process? And of course, line speed, right? Do you have a conveyor system with a little bit of product moving at a slow rate of speed? Or do you have a process with a lot of product moving at a very high rate of speed? Obviously, that will affect detectability. And finally, the detector equipment themselves, right? What's the size of the detection equipment? What's the aperture setting that's actually doing the detectability? Size and power of the equipment and the settings that they're on play an important role. At the end of the day, it's the end user's responsibility, the person that's actually manufacturing the product that's being tested. It's their responsibility to understand how all the variables in their system can actually affect their own individual process and hence the detectability of these materials in their process. Now, the data. We actually, with the support of one of our large material suppliers, Rochling Plastics, had this testing conducted. The equipment that was used was Inspex X-ray detection equipment and Safeline metal detection equipment. And the plastic pieces that we utilized were machined from stock-shaped sheets and rods. And again, the initial studies concluded that materials could be seen actually down as low as about 2 millimeter cubed, which is certainly much lower than the 7 millimeter FDA requirement. But again, very important to point out that those environmental factors will play an influence and have a huge role in exactly how detectable each plastic piece will be in each manufacturing scenario. But for our test, I'll explain what we did here. First up is the metal detection data. And there's two sets of detection data here based on two different plastics. On the left-hand side, we have metals, and the plastic associated with this test is the Cystrin C MDT, which is a metal detectable acetyl. And the data on the right-hand side shows the metals and in association with the Polystone M MDT, which is a metal detectable ultra-high molecular weight polyethylene. And again, Safeline metal detectors were used. And the way this worked was we first set up the detection systems based on a known metal or stainless steel standard. And then once we set up to the stainless steel standard, we ran the various ferrous and non-ferrous metals and plastics through and saw actually how small we could actually detect those different materials with the same setup. So to explain the first line here, you notice on the left-hand side we have a stainless steel sphere of 1 millimeter in size, and we set the system up to be able to detect that 1 millimeter sphere. And one of the reasons we did that was most manufacturers used a 1 millimeter stainless steel sphere as a good standard. So when we set the system up to that stainless steel standard, you can see that when we ran the ferrous and non-ferrous metals through, those were actually resulted in detectability levels down to 0.7 millimeter. So those materials are actually even more detectable than the stainless steel. And that held true as we went on down to different levels, different detector levels. Traditionally, the ferrous and non-ferrous materials were more detectable than the stainless steel. Plastic, on the other hand, was not as detectable, as we already mentioned. Actually, we saw the metal detectable acetyl vary from 2.45 millimeter cubes all the way up to about 5.6 millimeter cubed. And same held true when we looked at the data on the right-hand side, which is the same sets of data, but in comparison, we compared them to a metal detectable ultra-high molecular weight polyethylene, the Polystone material. And in that case, we saw plastic that varied from 2.33 millimeter cubed on down to 5.33 millimeter cubed. And basically what you ended up seeing was, depending on what your stainless steel setup was, we saw plastic that ranged anywhere from 2.5 to 3 times the size of the stainless steel. The good news is we saw, even though we saw cubes ranging from 2.5 to 5.5 millimeters in cubed, we were still well below that 7 millimeter requirement for the FDA. So hopefully this gives you a little bit of a good understanding for what you can expect from a metal detection equipment. Now, the X-ray detection equipment. Okay, in this case, you can see that we put the contaminants inside of a chicken breast, and you can see visually the level of detectability. So again, we're talking about contrast in densities here. The X-ray detection equipment is heavily related to density. So let's start with stainless steel. If we look at the stainless steel contaminant, here's a 1.5 millimeter sphere, and it's very small, yet very clear and very easy to see. So that would definitely be detected by the X-ray equipment. For comparison purposes, next to that is a row of glass contaminants, and those glass contaminants are ranging from 2 millimeters to 7 millimeters in size. And again, the glass appears very clearly and certainly detectable by the X-ray. The next row here are actually pieces of Teflon. Again, pieces of PTFE ranging from 3 millimeters to 9 millimeters in size. And again, you can actually see those quite clear. But that is virgin Teflon. That has no metal X-ray detectable additives in that. And why are they so clear? Well, the fact is Teflon is one of those heavier plastics with a specific gravity about 2 times that of water. And so as a result, you can actually see Teflon quite easily in the X-ray detection equipment. By contrast, over here is a piece of ultra-high molecular weight polyethylene, virgin grade, with no detectability additives, 5 millimeters in size, and you can barely see the shadow. That obviously would not show up on the detection system and would just move right on through and not be flagged. So hence where the danger comes in with standard plastics. Now, by contrast, here are your 2 X-ray detectable plastics. Again, the Polystone M XDT, the metal or X-ray detectable ultra high molecular weight polyethylene, and the Susterin C XDT, the X-ray detectable acetyl. And both of those are 5 millimeters in size and very easy to see in contrast. So to give you some relative term here, or relation, so you can have sort of an understanding of how the test went, this chicken breast moved down the production line at about 250 feet per minute, and you can see the level of detectability even with those speeds. So again, hopefully it gives you a little bit of an understanding of what you can actually expect to see from these detectability polymers. In summary, both metal and X-ray detectable plastics can greatly enhance food safety when aligned with detection equipment. But these materials are only detectable down to about 2.5 to 3 millimeter cube size, depending on the material and depending on the application. And as we mentioned, of course, detection settings, food product medium, and many other factors can influence this level of detectability. So each application needs to be fully understood, fully tested to ensure the level of detectability is acceptable for each individual application and product environment. Now, additionally, the end user is responsible from that standpoint. The end user, the manufacturer of the product, needs to conduct their own testing to have their own understanding of how their system and the detectability of the polymers work within their system. So I can't stress that enough. Now, Boedeker Plastics. How are we there to support you along your journey with these polymers? Well, first and foremost, Boedeker Plastics is there to supply material. We're a distributor with over $20 million in plastic stock shapes available, cut to size, same-day shipping all over the globe. So we can get you material and get it when you need it, including these detectable polymers. Beyond that, we're ISO 9001 2015 certified. We're 21 CFR 820 certified. And we also offer, beyond just selling material, we have plastic part capability. We have a high precision machine shop with over 100 CNCs that are available to manufacture parts to print. We also offer injection molding as well. So beyond just materials, we can also supply parts. And we have technical support and services available to answer just about any question you have or concern. You know, we can help you with choosing the right plastic for your application and answer questions about mechanical properties and really help you through the entire process. So we have that available for you as well. Beyond that, we have food and beverage and pharmaceutical specialists that are focused on this industry with the latest knowledge required. And we incorporate equipment into our process as well that's required for these industries, such as UDI laser marking for identification purposes. Also process validation in our manufacturing facility, requirement of the medical industry. But because we do it for the medical industry, it really, the benefits of the process validation spills over into other industries as well, and certainly food benefits from that as well. With our quality system, we also offer state-of-the-art metrology equipment for enhanced measuring and to ensure that we're giving product to print as required by the customer. And I'll also add the just-in-time supply services, again, for machined or injection molded parts, Boedeker offers in their environmental warehouse, environmentally controlled warehouse, the ability to stock finished part components as well. So you put the onus on Boedeker to hold stock, and we ship it out as you need it. And we call that our just-in-time supply services. So just a few little tidbits at the very end here to show you that Boedeker's there for you throughout the whole process. So hopefully you gained a little bit of insight on the detectability of plastics. We do have a white paper with this data that's available in a little more detail, and it's available for download. You'll see a link for that tied to this webinar. You'll also be able to get that off of our website as well, along with a lot of other great information at www.boedeker.com. And again, thank you for tuning in, and we appreciate your time, and don't hesitate to give us a call.